Okay. So yun. So I gave you an assignment last time and hopefully you arrive with this answer. Ayan. So hopefully ganyan yung nakuha niyo yung sagot ha. Okay. So bakit ganyan yung naging answers natin? Primarily because in the SASB process, ang ating analyte is the strong base, SBSA pala rather. The analyte is the strong base, no? So we should expect that the pH initially and at the pre-equivalence points should be greater than 7 kasi base yun eh, 'di ba? So kailangan ganyan yung yun yung unang natin makuha, no? So again, kapag SBSA, expect nyo yung unang pH ay mataas, no? Kasi base yun eh. And then gradually it will decrease, no? Down to pH equals 7, so the neutral pH. And then after the addition of excess acid titrant, you should expect na yung pH ay below 7. Okay? So this is the answer. If you were able to graph it, pangit yung graph ko kasi ang pangit ng aking intervals, no? Pero it should look like this, no? So yan. Also, ayan, screenshot nyo na lang. Also, I have uploaded on Canvas an Excel file now. So if you will go to your Canvas accounts now, hopefully na screenshot nyo na yan. Papakita ko lang yung Canvas. Okay. So if you go to your Canvas accounts, no, punta kayo in discussion. Ito, dito sa laboratory file, may in-upload akong titration curves na Excel file. Okay. So I want you to download that and try to practice solving for the pH, no. Okay? Kasi nilagay ko na lahat diyan ng calculation, pati yung graphing, no. So it's up to you na lang to to use that as practice materials, no. Although magbibigay pa ako ng worksheets, no, by the weekend. Okay, para mas masanay tayo. Okay, so yun lang. So nag-upload ako dyan ng Excel file. You have the strong acid, strong base, strong base, strong acid, weak acid, weak base. Hindi pa naglo-load, no. Ayan, weak acid, weak base, and weak base, strong acid. Okay, so align natin yan sa discussion natin later. Okay. And so again, hopefully you arrive with this answer. Okay. So if you have any questions about the discussion, again, I highly encourage you to ask, no, para clear tayo. Okay, kasi again, ang daming equations, no. Pag nalilito pa rin tayo, then medyo bad sign 'yon. Kasi imagine nyo yung exam, isang sentence lang yon, ano gagamitin mo sa lahat ng equation na sinabi ko, no? So, kailangan alam natin kung ano yung gagamitin, okay? So, yun. So, again, any questions are welcome, no? Para clear ang mga bagay. Okay. So, let's now continue on the weak acid strong base titration, no? So on the weak acid strong base titration, we have the weak acid as our analyte rather. No? So our weak acid is analyte, no? Siya yung nauna, followed by the strong base as the titrant. So if I will ask you, if I will draw the curve, ano itsura nun? Ano itsura ng curve? So, kailangan mababa yung pH on the left and as you go to the right, tataas yung pH. Kasi you started from a weak acid, then magdadagdag ka ng strong base. No? So, the pH must be increasing. Okay? So, again, similar to the previous types of monoprotic titration we had, meron din tayong apat na stages dito. Okay, so we have the initial, pre-equivalence point, and the post-equivalence point na. And alam nyo na rin dapat na kapag magsosolve kayo, you should always look for the equivalence point muna. No? Hanapin nyo muna si VTEP. No? And then after identifying sino si VTEP or the volume of titrant at equivalence point, then you can check, no? You can check kung anong stages yung ibang volume. Okay? So, ganun. Then, pag alam mo na yung kung anong stages sila, you have your corresponding pH calculation equations, no? So, again, ang pinapakita ko dito is yung mga H concentration, OH, no? So, alam nyo na dapat i-convert yan to pH. Okay. So, ngayon, let's talk about the species present because that will enlighten us on bakit ganito yung equation. Okay? So, yan. So, let's start, no? So, initially, so your analyte is the weak acid. So, ibig sabihin nun, ang ating species present ay yung ano lang, weak acid and the water. Okay. So, of the two species present, sino sa kanila ang major contributor for the pH? Obviously, the answer must be the weak acid, no? Okay. Okay, so the weak acid will contribute to the pH. And how do we solve for the acidity or the concentration of hydronium ion for a weak acid? No, that can be derived from the acid equilibrium constant. So you have your HA in equilibrium with H plus and A minus, the conjugate base. So if you write the Ka, that will be concentration of H plus, concentration A minus divided by HA. Okay? Okay, so ano ginagawa natin dito? Diba last time we solved for X, no? So we assume X yung concentration ng products. And then we have here the concentration of acid minus X. And that's equal to Ka. And because of this, because of the small x approximation, ano nangyayari? Yung minus x sa denominator, that can be reduced, no? Zoom in tayo dito. Yan. So, the minus x in the denominator, it can be reduced to CHA na lang, no? Kasi sabi natin small x, di ba, last time? Okay. So, the equation can be reduced to Ka over CHA. Yan. And then, since we are looking for x, all you have to do is to get the square root of the product of tsaka. Okay. So, yan yung gagamitin natin. Okay? So, this is just a, paalala lang ulit. Recall lang natin yung ganitong ganap. Okay? So, ito yung reason why we need to use this. Okay? So, I know you are very familiar with this one because we discussed this in depth last time now. Okay? In the previous chapter. Okay? So, square root of tsaka gagamitin natin. Again, in the titration case, we will be assuming that the ratio of concentration of acid over Ka is greater than 1,000 always. No? Assume na natin na ganun yung case, no? So that mas madali yung calculation natin. However, on other references, they will prefer to use this equilibrium. Okay? Pag nagbasa kayo ng textbook nyo, either that's Skug or Klein, o kaya nanood kayo ng ibang YouTube channels like Khan Academy, Professor Dave, no? Or others, no? Even sa Crash Course, meron na ito, no? So, pag nanood kayo ng ibang YouTube channels, they will give you this equation. However, in our case, no, for simplicity, mag small x approximation, okay? Because kahit naman ikaw ay small x approximation, then the ratio of acid and the Ka is not greater than 1,000. Medyo malapit yung pH na makukuha mo doon. And again, ang ating exams naman, no, yung final exam ay multiple choice, no? So, having an approximate answer will give you an idea kung sino yung pipiliin mo sa choices mo. Okay? So, yun. So, okay na tayo dun sa approximate answers, no? Okay? So, yan. So, that's the reason why our equation for the initial is this. And then, pre-equivalence point, that means you are adding the strong base titrant. What happens now when you add the strong base titrant? Ano nangyayari? So your acid becomes neutralized, no? Neutralize siya. Okay, so let us write the equation. So you have the HA. Let's say sabihin natin sodium hydroxide. Ano mangyayari? Magiging yan? Water and NaA, no? Okay. So, syempre, hindi yung complete pa kasi pre-equivalence point pa tayo. So that means you have the presence of HA and the conjugate base. No? And again, as I told you last time, if you have a presence of the two species, that means may buffer system. Okay, so since we have a buffer system, we have to use the Henderson-Hasselbalch equation. Since this is acidic solution pa, we use the acid version of the Henderson-Hasselbalch equation. Okay, so if you could recall, pH is equals to pKa plus log of the conjugate base over the concentration of the acid, no, for the Henderson-Hasselbalch equation. So yan. Take note that yung HA natin dito nababawasan. Okay? Nababawasan yung concentration ng HA natin. And yung concentration ng ng conjugate base na dadagdagan. Okay? So you should take note of that, no? So ibig sabihin, paano ko po i-express yung amounts ng conjugate base and the acid, no? Okay? So ano ba yung conjugate base? Saan ba galing to when we add the titrant, no? So we can express this as MTVT, no? So yan. So bakit? Kasi nagkaroon lang tayo ng conjugate base, no, when we add the titrant, 'di ba? Kaya we can express the moles of the conjugate base by multiplying the molarity of titrant and the volume of titrant. Okay? Ganun yung approach sa titration. Alamin mo saan galing. Okay? Kasi it's either analyte or titrant lang yun galing. Okay? So, yun. So, again, to determine the moles of the conjugate base, ayan, MTVT. Kasi sa titrant yan galing. Yun. Nung nagpatak ka ng titrant, dun siya lumabas. Okay? So, yan. How about the HA? No? So, for the HA, sabi natin nababawasan yan. So, ibig sabihin, yung acid, nababawasan dahil nagdagdag tayo ng base. No? Okay? So, similar lang to dun sa acid-base titration. Anong equation sa tingin nyo gagamitin natin dito? Hindi ko mabura. Yan. Ayan. Erase na. Ano sa tingin yung equation gagamitin natin to solve for the moles of the HA remaining? That is mole acid minus mole base, no? Or MAVA minus MTVT. Okay, take note of that. Again, bakit naging ganito? So, yung moles ng ating conjugate base, paano natin naging ginawang ganito? Kasi galing yun sa titrant, no? When you add titrant, dun siya napoproduce. So, ibig sabihin, the number of moles of the conjugate base depends on the moles of the titrant added. Kaya ganyan yung equation. How about itong nasa baba? In the denominator, we just express that, we just express the remaining moles of the acid or with the remaining concentration of acid. Okay? So, yan. So, ganun. Kaya ganyan. Mole acid minus mole base or MAVA minus MTVT. Papansin nyo, ba't di ko po siya dinivide sa V total? Okay? Kasi, ano ba yung final volume nito? Is it the same as the final volume of this one? Yes, kasi parehas na container lang sila. Okay? Iisang container lang sila nakalagay eh. So again, kapag ito naka-divided by sa V total, ito naka-divide sa V total, you can cancel the V total. So you can express this in terms of the moles na lang, no? Okay? So hindi na molarity. Okay lang kahit di na molarity. Moles na lang, okay? Kasi again, yung V total, pwede mo i-cancel, no? Pwede mo siya i-cancel out, no? Kasi yun. Ito, diluted to. Ito, diluted to. So, i-cancel mo na lang yung volume total, no? To simplify your equation. Okay? So, yan, no? Hopefully, clear tayo kung saan nanggaling to at paano nakuha to. Kasi nababawasan to. Ito naman, dumadami because of the addition of titrant. Okay? So, yan. So, that is our pre-equivalence point equation. No? On the next one, we have the equivalence point. So, ano meron dito sa equivalence point? On the equivalence point, all of the analytes, no, lahat ng analyte, they are completely titrated na. Okay? So they are all completely titrated. Okay? So ano nangyari? Na-convert na sila lahat into the conjugate base. Okay? So yan, naging wala na to. Ubos na yan. Kasi tapos na yung reaction. Naging ganito na. Sodium acetate na siya in this example. Okay? So, naging conjugate base na lahat ng acid. No? Tapos na yung reaction eh. Ibig sabihin nasa product side na tayo. Okay. So, ibig sabihin nun, of the two species, no, the water and the conjugate base, which of them will contribute sa pH? Yung water, yan yung nagko-contribute sa pH natin noong strong acid, strong base titration, di ba? And the strong base, strong acid titration. Water lang kasi nandun eh. And the salt. But this time, we have the conjugate base. No? And the conjugate base has a basic property. No? Ibig sabihin, ito yung magko-contribute sa pH. No? Take note of the words na ine-emphasize ko kasi baka lumabas yun sa exam or sa quiz. Okay. So, at equivalence point, the conjugate base contributes to the pH of the solution. So, since base to, OH makukuha natin. Okay? So, ganun ang idea. So, ano ba yung equation na nangyayari pag nandito na tayo sa part na to? So, what happens on the equivalence point is that our conjugate base will react with the water, and that is in equilibrium, and makakagawa tayo ng HA plus OH. No? But again, yung HA virtually ubos yan. OH lang talaga yung matitira. Okay? And this equation is actually the reverse of the Ka equation. Okay? Kabaliktaran lang to ng Ka equation. Okay? So, this is actually the Kb, no? Okay? So, again, kapag yung acid equation binaliktad mo, you will get the Kb. Okay? Kaya, ayan. So, kasi andito yung acid, andito yung conjugate base. Eh, di ba kanina, andito yung acid, andun yung conjugate base. So, Ka yan. This time, baliktad tayo. Ang base andito, ang acid andon. So, ibig sabihin, ang reverse ng Ka ay Kb. Okay? So, that's why, if you want to solve for the concentration of this, you can apply the equilibrium calculation. So, ang lalabas doon ay Kb equals, okay, we assume na equal tong dalawa. So, you will have x squared divided by the concentration of base minus x. Apply the small x approximation, mawawala yan. So, x is equal to the square root of Cb Kb. Okay? So, yun yung dahilan bakit ganito yung sagot natin. Or the base is the conjugate base na. Kaya Ca minus nilagay ko doon. Okay? So, Ca minus are the concentration of the conjugate base times the Kb. Okay? So, yun yung dahilan bakit ganyan yung equation. Because of this and the equilibrium condition. Okay? Take note of the mga nangyari. Kasi mauulit-uli yan pag weak base, strong acid titration tayo. So, yun yung equation natin. To solve for the concentration of the OH, if you want to get the pH, convert this to POH, then subtract this sa 14. No? So, 14 minus the POH is the pH. Okay, the question next is, paano ko kukunin yung concentration ng conjugate base? Yung Kb, paano ko rin kukunin yon? Okay? So, if you are given a Ka, okay, so erase ko lahat ng notes ha. If you are given Ka, paano mo kukunin yung Kb muna? Okay? Take note that Ka times Kb equals Kw, or 1 times 10 raised to negative 14. So, ibig sabihin, if you are looking for Kb, just divide Kw by the Ka. Okay? So, yan. Now, clear tayo doon kasi ginagawa natin yung last chapter, di ba? So, we have no problem with the Kb. However, paano yung concentration ng conjugate acid? Okay? Conjugate base rather. Okay. So let's look at the stoichiometry equation natin kanina. Now, producing H2O plus NaA. Okay, and this one is the conjugate base. Okay, so if you're going to do stoichiometry, sige. Balik tayo sa inorg chem last sem. If you're going to apply stoichiometry concept here, how are you going to get the concentration of this one or the amounts of this one? Is it sa titrant or sa analyte mo kukunin? Complete na yung reaction dito ha. Take note, iba yung case natin dito sa dito. Ibang stage na tayo eh. Okay. So since the reaction is complete, wala na tayo ng reactants. Products na lang meron. Pero let's trace back saan galing yung mga A-. Diba dito sa taas, sabi natin, because of the addition of titrant, lalabas yun. Okay? Kaso, at equivalence point, wala na tayong dinadagdag. Okay? So lahat sila na-convert na doon. Paano mo kunin yung dami nito sa analyte? Yun, sa analyte yun manggagaling. Kasi if you look at the equation, yung analyte lang naman yung may A, no? Yung naawala eh. Again, iba yung condition dito ha, equivalence point na tayo eh. Iba yun sa sinabi ko kanina dito kasi pre-equivalence yun. Okay. So for each stages, iba-iba yung nangyayari, di ba? Okay. So ang nangyayari is that at equivalence point, no, lahat ng ating HA na convert na into the conjugate base. Yun yung idea ng chemical equation na to. Lahat ng ito na-convert na into that. Okay? So if you want to determine the concentration of this, kunin mo yung moles neto and you divide it by the total volume of the solution. So ano ba yung moles neto? That's VAMA, MAVA, di ba? Molarity analyte, volume analyte. Yun yung moles ng HA. Then stoichiometrically, 1-to-1 lang naman yung ratio. So, ibig sabihin, the mole of this is equal to the mole of this. No? At equivalence point. Again, at equivalence point. No? Okay. So, kung ilan mole to, yun din yung mole nun at equivalence point. And since concentration kailangan natin, you have to divide it by the total volume of the solution. Bakit total volume? Kasi nag-dilute tayo. Okay. Take note, for every stages na di-dilute yung ating solution. That's why we always have to divide it by the V total. Okay? So, yan. So, yan na. So, yan yung dahilan bakit ganito yung equation natin. So, saan to galing? Sa equilibrium. Saan to galing? Sa stoich. Okay? Pinaghahalo-halo na natin lahat ng equation. No? Okay? So, again, the case for equilibrium, the case for equivalence point is different sa pre-equivalence point, no? Sabi ko kanina, ito galing sa titrant. Okay? Kasi if you apply the stoichiometry, hindi complete yung reaction kasi. So, hindi mo pwede gamitin tong stoich na to. Okay? Hindi complete yung reaction. So, ibig sabihin, you have to analyze talaga. Nadadagdagan lang to because you add titrant. So, sabi natin, MTBT to. But in this case, sa equivalence point, complete na yung reaction. So it means we can apply the stoich equation. Okay? So yun lang yung idea. Ayun, medyo contrasting siya. Yes, pero ganun talaga na. Okay? Mag-iba yung case dito sa case dito. Okay? So i-note nyo yun sa notes nyo. Okay? Kasi mamaya yung quiz, malay nyo, no, yung exam natin, wala naman palang solving, puro puro conditions. So kailangan alam nyo bakit, no? Okay? So to make everything simple, you can use the equations na lang. Okay? But take note na mas maganda yung alam nyo saan sila nanggaling. Okay? So yan. So this is the equation for the equivalence point. And after adding the excess titrant, we are now on the post-equivalence point. So at the post-equivalence point, we have the following species present in our Erlenmeyer flask. We have water, the conjugate base, and the excess base. Of the three species, which of them will contribute to will be the major contributor to the pH of the solution? Pwede ito, pwede ito. Pero, sino mas malakas? Yung base. Kasi strong base to, ito weak base to, di ba? Okay. So, yan. So, mas malakas tong excess base kasi strong base to eh. So, the pH is heavily reliant on the amount of the excess base. Okay? So, that's why our equation here is, ayan, simple equation na tayo ulit. So, that's the concentration of OH equals to the excess titrant minus the analyte divided by the total volume. Familiar tayo dito. Okay? By the way, no, hindi ko na-share to last time. This equation can be reduced to this one. Volume of titrant minus volume of titrant at equivalence point times the molarity of titrant divided by V total. Okay. Para hindi ka na mag-type ng marami. So, pwede ganito na lang. Okay. Volume titrant minus volume titrant at equivalence point, empty. Kasi pag pinag-subtract mo to, basically, ang kinukuha mo lang is yung mole ng titrant na sobra. Okay. Another way to determine the excess mole of titrant is this one. Yung sobrang volume ng titrant na lumagpas sa equivalent point times the molarity of titrant. Okay? So, yun yung nangyari. Ang kinukuha mo kasi dito is sobrang moles ng titrant. Ito rin, pwede mo rin kunin yun dito. Okay? So, this can be applied sa previous discussions natin. Kunwari, sobrang acid kinukuha mo, edi ano, Vt minus Vet endpoint times molarity analyte, molarity ng acid, no? Kunwari, sobrang base hinahanap mo, you can apply this equation. Okay? Kasi ang kinukuha mo is yung sobra lang, no? Yung sobra lang. Kaya, ayan. Yung sobrang volume times the molarity of titrant, yun na yun. Yun na yung sagot. Divided by V total. Okay? So that is the reason why we have the following equations here. Again, lahat ng ito can be explained when you know kung ano yung mga species present sa solution. Kasi pag di nyo alam kung ano yung species that is present in our solution, hindi mo alam yung magiging equation, no? Okay? So, ganun. Yun yung importance ng knowledge ng species present, no, to the pH calculation process. Okay? So, all in all, you can just follow this, no? Kung ayaw mo na ma-complicate mga bagay, sundin mo na lang, no? Pero again, we will try to develop the critical thinking skills, no? Kaya kailangan alam nyo bakit naging ganun, no? Kasi malay nyo, no? Magturo din kayo, no? Magturo din kayo in the future, no? Mabigyan kayo ng anakem na subject, no? Kunwari lang, sa ibang school, yung mga ilang medtech yung nagtuturo ng anakem, no? Pero sa FEU, mga chemist na nagtuturo ng anakem, no? Kasi ito yung sanay kami. Okay. So, yan. So, kunwari, nasa ibang school kayo nag-apply, no? O, pinagturo kayo ng anakem, kailangan alam nyo to, no? Kasi I have a friend na medtech, no? Na, and syempre, di siya chemist, no? So, ano siya, RMT. So, itong equations na to, sinasabi niya lang as is sa students niya, ito yung equation gagamitin mo dyan, ito yung equation gagamitin mo dito. Okay. But as a chemist, mas alam namin, bakit ganito yung equation na gagamitin mo? And hopefully, ganun din yung ma-develop yung skill. Kasi malay nyo, magturo kayo in the future. Tanungin kayo ng student nyo, bakit po ganyan? Okay? Kasi nung student ako, ganun din ako. Bakit po ganyan yung equation? Okay? So, may explanation sa lahat ng bagay. Okay? Ang hindi lang natin ma-explain is yung mga ilang bagay na magical. No? For example, bakit may dolomite ulit? No? So, yan. So, yan yung mga magical na bagay na hindi natin mapaliwanag. Pero ito, this is science. No? And it can be explained. Okay? So, those are the equations necessary to carry out the weak acid strong base titration, no? So, ito yung curve natin. So again, familiar na kayo dito. What's distinct with the weak acids or the weak bases na pag tinitrate sila with the strong counterparts is ito, may bump, no? Joke time lang ba tong bump na to? Hindi, no? Kasi dun sa example na binigay ko, okay, so dito sa Excel na binigay ko, you have the strong acid, strong base, weak base, strong acid. We have the weak acid, strong base. Okay. So, punta kayo sa right side, tignan nyo. Ayun, no, may bump. Okay. So, may bump siya doon. So, hindi yung joke time, no? Yung bump na yan, meaning yan kasi is may buffer system time. And as you can see, the pH slowly increases here. Dahan-dahan lang, and then suddenly inflection point, and then post-equivalence point. Okay? So, ito, yung first derivative, nilagay ko lang talaga yan para malaman nyo na at inflection point, andun yung highest derivative, ibig sabihin, andun yung endpoint. No? Pero hindi ko papagawin sa inyo yung first derivative, no? Sa ano na yan, sa BS Chem na yan, no? So, ang focus nyo lang is itong curve na to. Okay. Second derivative pa nga namin to eh. No? Wala lang. Ganun talaga pag chem. Pero kayo, ang titration curve lang ang kailangan natin. Okay? So, yun, again, may bump yan. The bump is, tells us na meron tayong buffer system. Okay? Because this is an equation. We have HA and A minus present. The A minus is present because you are adding titrant. No? However, at this point, we have the equivalence point. Ano nangyayari? Lahat ng acid na convert na to A minus, and the A minus or the conjugate base dissociates then, no? It reacts with water to produce the base. Okay, kaya CBKB equation natin dito, square root of CBKB. And post-equivalence, the excess base will determine the pH of the solution. No? Kung gaano kasobra yung base, yun yung pH ng solution. Okay. Also, take note, no? Kung ang strong acid, strong base, ang equivalence point niya ay 7, what is the equivalence point, no? Pag tayo ay nasa weak acid, strong base, ano yung equivalence point natin sa tingin nyo? Based on the knowledge of these species present, ano sa tingin nyo yung magiging pH ng equivalence point? Is it 7? Is it higher than 7? Or is it lower than 7? Any idea? Ano kaya yung magiging pH ng solution ko at equivalence point? Any idea lang? Okay lang? Kasi tatlo ng options nyo. 7 pa rin, greater than 7, or less than 7. Hulaan nyo. 7. Okay. Other ideas from the class? Okay. So, may isang vote tayo for 7. May isang vote tayo less than 7. Okay. Yung iba. Hula tayo. Any ideas? No? Yung iba baka kumakain na ng lunch na. Okay. So, ang sagot doon is greater than 7. 7 din pa. Okay. So, ang sagot doon is greater than 7. Okay? So, iba siya sa strong acid, strong base. Kasi sa strong acid, strong base, ano yung natin? H plus is equal to square root of Kw. No? But again, kapag weak acid, strong base titration, tignan nyo yung equation, no? Ano meron tayo? Meron kasi tayong conjugate base, no? And conjugate base is, from the word itself, base, no? So that means the equivalence point pH is greater than 7. Okay? So the pH at equivalence point is greater than 7 parate, no? Kapag weak acid, strong base titration. Okay? Yun na yung hindi na siya automatic 7, baka ilagay nyo 7, no? Kasi sabi natin, ang nangyayari at equivalence point, may conjugate base tayo. From the word itself, base, no? Ibig sabihin, mataas yung pH, no? So, greater than 7 yun. Kasi at pH greater than 7, basic yung solution. Okay? And what we have here is a basic solution. Okay? So, yun yun yung kailangan natin i-take note. Malay nyo, nasa quiz yun. The pH of the pH at equivalence point of a strong weak acid, strong base titration is pH greater than 7, less than 7, equal 7. Sagot nyo is greater than 7. Because At equivalence point, conjugate acid name meron tayo. Ay, conjugate base pala. Okay. So, conjugate base na tayo, meron tayo. And from the word itself, conjugate base. Base, no? Ibig sabihin, basic, no? Greater than 7 ang sagot natin. Okay? And kung titignan nyo rin yung equation natin, ano nakalagay? OH, no? So, ibig sabihin, greater than 7 talaga yung pH dito. Okay? So, yun yung yun yung mga yun yung mga loopholes dito, no? Kasi malay nyo, yung dalawa kasi quiz natin dito, hindi ko pala nasabi sa inyo last time. Dalawa quiz natin dito. Kasi this is a topic that will heavily, ito yung topic na kailangan nyo talaga mag-gets, no? Hanggat maaari, kailangan talaga mag-gets. So, since this requires mastery, dalawa quiz natin dito. Okay? So, yun yung idea. Okay? So, siguro yung isang quiz, puro conceptual lang. Yung isang quiz, puro solving, no? So, pwede ganun yung gawin ko. Okay? So, ganun ha. Pag conceptual, alam nyo na mga mangyayari. Tatanungin ko kayo, ano ang pH ng solution pag weak acid strong base? Sagot ay greater than 7 because of the presence of the conjugate base at equivalence point. Okay. So, yun yung mga yun yung mga knowledge na gusto ko i-impart na. Okay. Hopefully, na-note nyo yun, sulat nyo. Always ask yourself, no, pag chemistry, bakit ganun? Okay, bakit ganun? Okay. Bakit greater than 7? Because of the conjugate base. Kasi ang conjugate base ay base. Ibig sabihin, basic solution. Okay? So, yun yung yun yung logic doon. Then ito, again, post-equivalence point, ang pH ay greater than 7 na talaga. Okay? So, let's practice. Okay, if you have any question, ask nyo na ha. Okay. Pero hopefully mga pointers na sinabi ko, yung in-emphasize ko, yung inulit-ulit ko, isulat nyo rin siya. Okay? Kasi yun yung mga lalabas, no, sa quiz natin. And sa exam, no. Okay. So, yan. Malapit na exam nyo. Almost a month na lang, no. So, ayan. Kailangan ngayon pa lang nagno-notes na talaga kayo. Okay. So, let's have this problem. Generate a titration curve. Hindi na ako magka-curve, ah. Okay. So, kayo na lang mag-graph. No? Generate the titration curve for the titration of 50 ml of 0.1 molar acetic acid, or we can abbreviate that as HOAC. Ka is 1.8 times 10 raised to negative 5 with 0.1 molar sodium hydroxide at 25 degrees Celsius. Okay, so sige. Ano yung mga takeaways natin last time? Sabi ko kung ano yung unang sinabi, yun yung Analyte, di ba? Obvious naman. Okay. So kung ano yung sinabi, yun yung una, lumabas na yung sagot, di ba? ayaw na magpa-solve. So kung ano yung unang sinabi, yun yung Analyte, no? And we know that acetic acid is WA, no, weak acid. Paano mo malalaman kung weak acid? If it is organic acid, o kaya kapag binigay yung Ka. No? Kasi kapag strong acid yan, hindi bibigay yung Ka. Okay. Pero it doesn't mean na pag hindi ko binigay yung Ka, strong acid agad yun ha. Kailangan familiar tayo sa mga acid na may Ka values. Balikan nyo yung notes natin sa chapter 4. May table doon, di ba? Yung acid and the corresponding Ka. So yun, dun nyo pwede pagbasihan yung sagot nyo. Okay. So, acetic acid, ito kabisaduhin nyo na, paulit-ulit lalabas tong acetic acid. So, 1.8 times 10 raised to negative 5 ang kanyang Ka. So, ibig sabihin nun, because of Ka, we can tell na ito ay weak acid. With 0.1 molar sodium hydroxide. Ito yung late na sinabi. Ibig sabihin, ito yung titrant. And the titrant is strong base. No? So, we have a WASB. No? Hindi siya WAP, no? WASB. Okay? Yeah. So, weak acid, strong base titration yan. Okay? So, again, kung ano mauna, yun yung mauuna dito sa abbreviation. Analyte, titrant, weak acid, strong base. No? Okay? So, since you know the condition, ito na yung 4 na equations na gagamitin natin. Again, important yan na alamin mo kung ano yung species present. Strong ba sila or weak? Sino yung analyte, sino yung titrant? Kasi again, 16 yung equations natin. Okay? So 16 equations na yon, ano yung combination doon na gagamitin mo? That can be determined when you identify your species present. Okay? So clear tayo dito. Nauna to kaya analyte yon. Acetic acid is a weak acid. So WaSb tayo. Okay, so what's next? Alam na natin kung anong type ng titration tayo. Ano susunod? Hanapin si VTEP. No? Okay, routine calculation tayo. Ganun pa rin. Yung equation lang yung nagbago. No? Pero pag hahanap ng VTEP, same process pa rin. Ano yung condition natin at equivalence point? We say that mole titrant equals mole analyte. Diba? So we can express mole titrant as molarity titrant and the VTEP, siya yung hinahanap natin. And MAVA. Hanapin si VTEP na best friend natin. So that's MAVA divided by MT. Plug in the numbers. We have 50 times VA. Pinagbaliktad ko pala. So that's 0.1 times 50 divided by MT. 0.1. Cancel. Okay, so basically, VTEP is 50 ml. Okay? Bakit nag-cancel ako? Kasi para siya 0.1 molar. Hindi, cancel mo na lang. Okay? So, VTEP is 50 ml. Okay. At that point, dun mangyayari yung equivalence point. No? So, ibig sabihin, tapos yung titration dyan. Okay? So, again, routine process tayo. No? Yung step 1 and step 2, pare-parehas yan all throughout. Hanapin mo kung anong species meron ka, and then, hanapin mo si VTEP. After nun, you assign the stages. Diba? Yun yung step 3 natin. Routine calculation tayo, ha? So, masanay na tayo. So, yung 0, malamang initial yan. Then, yung mga hindi, edi pre. And then, yung lagpas sa 50, yun yung post. Okay? So, yan. And you now know the stages and alam nyo na rin yung equations na gagamitin. So, let's solve for the pH of the solution. Okay. Initial. So, since this is a weak acid, the concentration of H plus is the square root of Chaka. Okay. So, that's the square root of Chaka. So, plug in natin yung Chaka. Okay. So, that's 0.1 molar times 1.8 times 10 raised to negative 5. Plug in, no? Kunin nyo na yung pH, no? May calcu pala ako dito, no? Bakit ako, dinownload ko to sa Casio. So, kung wala kayong calculator na cycle, download kayo nito. Meron tong equation din eh. Free trial to for 90 days, no? Download nyo na. So, kunwari, wala kayong stat calcu, wala kayong pang equation, kunwari quadratic, download kayo nito. Naka-laptop naman ata mostly sa inyo, no? So, download nyo na, ha? Yan. The square root of Chaka, so 0.1, ay. Yan, so 0.1 times 1.8 times 10 raised to negative 5. So this is the concentration of acid. Negative log of the answer is the pH. Okay? Ginanito ko na para alam nyo kung ano yung pinagpipindot ko sa calcu ko. No? Pagpapahingahin ko muna ang calcu ko. So yan. So para alam nyo rin yung ginagawa ko sa calcu. So pH is 2.87. Again, bakit naging ganun, sir? Ganito. Negative log mo ito. Negative log mo to, ha? Kaya yan yung ginawa natin. Yun. Okay? Next one. Tapos na tayo. Pre-equivalence point. Again, at pre-equivalence point, the equation to be used is the Henderson-Hasselbalch equation. Sulat ko dito sa gilid. Ay, lumabas na yung sagot. Yan. So, Henderson-Hasselbalch Equation, that's pH equals pKa plus logarithm of the conjugate base divided by the concentration of the acid. Take note that the acid is nababawasan. Okay? So, we expressed that as MAVA minus MTVT. And yung concentration ng conjugate base na dadagdagan when we add the titrant. No? So, that's MTVT. Again, contrast yan dito sa EP. No? Okay. So, may contrasting statements pero yun, sana clear. Kasi sinabi ko na kanina explanation. Hindi ko na ulitin. Okay? So, yan, nadadagdagan ito dahil sa addition ng titrant. However, ayun, hindi natin pwede gamitin yung stoic dito. Ito lang. Ayan, plug in natin yan dito sa sa 10 ml and 25 ml. Okay? Sulat ko muna para alam niyo yung pipindutin niyo sa calcu. By the way, pKa. Ano pag pKa? Negative log ng Ka. 'Di ba? So negative log. Lagay ko dito yung yung keylog ko para alam niyo yung pinipindot ko. Ayan. So that's negative log of 1.8 times 10 raised to negative 5. Enter. Ayan. So the pKa is 4.74. Okay. Note na natin dito. 4.74. Okay. So hopefully nakuha nyo yun. 4.74 na pKa. Then, ito. MTVT. MAVA minus MTVT na lang. Okay. Sulat ko muna para masundan. pH na yung makukuha natin dito ha. 4.74 plus log MTVT. Ibahin ko yung color. Black na lang. Pag titrant, black na. Kasi ganun gagawin ko. 0.1 times 10. Pag Analyte, oops, nag-block yung buong screen. Pag Analyte siguro, orange na lang. So, MAVA, so 50 times 0.1. Okay? Minus yung black. 0.1 times 10. Sulat ko rin yung sa baba ha. Hopefully, may sulat nyo na maayos. 4.74 plus log. Nanginginig yung aking kamay. Titrant, black yan. So, 0.1 times 25. Okay. Analyte is kulay orange. Useful to, no? Yung mga colored, no? Kung marami kayong colored ball pens, no? Gawin nyo yan para alam nyo, ito, titrant to, ito, analyte to. Okay? Kasi pag iisa yung color nila, parang, ano to? Ano to? Mamaya mapagbaliktad mo. Okay. Nung undergrad ako, syempre, PUP-an ako, 4 tayo. So, wala akong colored ball pens. Kaya kinabisado ko na lang talaga yung mga bagay. Pero kayo, siguro naman, may mga colored ball pens kayo dyan. No? May highlighter pa nga kayo, di ba? So, yun, i-highlight nyo na lang. Yun yung tip ko ha. Helpful yun. Okay. So, yan. Ayan, plug in na lang natin to sa calcu. Screenshot nyo na lang kasi pipindot ako ng calcu dito sa, dito. Okay. Clear natin to. Clear. Ano ba kini-clear yan? Ayan. For 10 ml, that's 4.74 plus fraction. Ay, hindi. Log muna. Log, then fraction On the numerator, that's 0.1 times 10 ml. On the denominator, mag-parenthesis tayo. Ay, mali. Parenthesis, 50 ml analyte, 0.1 molar analyte. Okay. Minus, parenthesis na naman. Okay. 0.1 times 10. Close parenthesis. Ayan yung sagot, 4.14. Ito yung calculator ko ha. Isang pasada lang gagawin ko para hindi sayang yung time. 4.74 plus log conjugate base 0.1 times 10 divided by acid MAVA minus MTBT equal sign 4.14. Okay, siguro okay na, no? Next, 25 ml naman. Pag 25 ml, palitan mo na lang yung nilagay mong volume. Ganun ginagawa ko kaya mabilis ako mag-solve. Gawin mo na lang yung 25. Huwag nyo i-clear agad, ha? Palitan yung numerator ng 25, yung denominator din sa titrant. Okay. Equal sign. Sagot ay 4.74. Yun. I still use the same equation. Yung volume lang pinapalitan ko, ha? Okay. Do you notice something weird sa ating sagot? May napansin kayong weird? Dapat meron. Okay, dapat meron kayong mapansin na weird. Ano yun? At 25 ml, the pH is equal to the pKa. So it appears that yung log equal siya sa 0. Is that true? Yes. No. Yun yung dahilan. No? And take note, no? At half the equivalence point, okay? At half the equivalence point, no? pH is equal to pKa parate. Parate. No? Okay. At half the equivalence point, the pH is equal to the pKa. Okay. Ano yung equivalence point? 50. Kapag dinivide mo yon sa 2, 25 yon. Ang pH doon ay kung ano yung pKa. Okay? So, take note nyo yan, no? Okay? Again, at half the equivalence point, ang pH ay equal sa pKa. Kahit di ka na mag-solve na ito. Ito na yun. Okay? Pero pinakita ko pa rin para alam nyo yung ipa-plug nyo. Diba? Parang ang weird, no? Pero ganun talaga, no? Bakit? Bakit? Sige. Kasi, ganito. At half the equivalence point, what happens is that the moles of the conjugate base and the mole of the acid is equal. True yon? Totoo ba yon? True that ba yon? True that? Tignan natin. What's 0.1 times 25? Siyempre, di ko kaya mag-mental. 0.1 times 25 na nga lang. Di pa minental, no? Okay, so, sige na. Para sure, no? Mamaya magkamali ako ng sinabi. That's 2.5 moles, di ba? So, the numerator is 2.5 moles, no? Yan yung moles ng ating conjugate base. How about the denominator, the remaining acid? Type nyo yung sagot natin kanina. Yung sinulat natin sa denominator. 50 times 0.1 minus 0.1 times 25. Nadoble yung minus ko. Tignan nyo. Yung remaining acid ay 2.5 moles din. And according to algebra, if you divide the same number, equal yun sa 1, di ba? Ibig sabihin, numerator is 0.25. 2.5 pala, sorry. So, 2.5 millimoles ang numerator. Ang denominator ay 2.5 millimoles din. Pag dinivide mo yun, edi 1, di ba? And what is logarithm of 1? Logarithm of 1 is 0. Okay? Yun yung sabi din ng algebra. Log 1 is equal to 0. Para sure tayo, pindutin ko yun, ha? namatay. Log 1, ang sagot, 0. Yun yung nangyayari at half the equivalence point. The logarithm part of the Henderson-Hasselbalch equation becomes 0 so that pH is the pKa. Okay? Diba? Ang dami kong sinabi. Yung mga ine-emphasize kong idea na yan, i-note nyo yan, side note, no? Kasi that will be helpful, no? Sa examination and sa quiz. Dalawa quiz natin, take note, no? So, lahat ng mga pinagsasabi ko, lalabas, no? Okay, so yan. Ayun yung takeaway natin dito sa part na to. Okay. Half equivalence point, pH equals pKa because mole conjugate acid, mole conjugate base equals siya sa mole ng remaining acid. So, nagka-cancel out sila and log 1 is equal to 0. Yan. Next one, EP. At the equivalence point, we have the base, no, which contributes to the pH of the solution. And since ang conjugate base ay base, OH yung kukunin natin. Okay, so the concentration of OH ang kukunin natin. Balik tayo sa kulay red. So tapos na ako mag Henderson something. Again, so equation ko kanina dito is CbKb, no? Or Ca minus. Ca minus yan dapat. Conjugate acid eh. Conjugate acid times the Kb. Paano kinukuha yung conjugate base, no? Kapag equivalence point na, ang sabi ko kanina, the concentration, lumabas na yung sagot. Sabi ko kanina, the concentration of the conjugate base, no? Ano yon? MAVA over V total. Okay? So, iba yon dito sa Henderson-Hasselbalch, no? Ibang equation kasi ito eh. So, ibang case tayo sa Henderson-Hasselbalch pag equivalence point na. At equivalence point, we assume that all analytes are converted to titrant na. Kasi tapos na yung reaction. So, we can use the Stoich na, no? Kaya MAVA over V total ang equation natin. Lahat ng analyte naging conjugate base na. Ayun. Yung dito kasi patsi lang nakukuha natin. Portions lang. Okay, so we get this na. Ayan. And ano yung Kb? Alam nyo, Kb. Kb equal Kw. Ibig sabihin nun, Kb equals Kw over Ka. Okay, so yan. Itong dalawang equation, pa-plug in ko dito ha. Okay, so medyo i-zoom ko to para mas makita. Zoom ko lang ha. Concentration ng base, okay. Habaan natin yan. Okay. Concentration ng base, MAVA over V total. Okay. Ano yung concentration ng analyte? Kulay orange gagamitin ko. 50 ml times 0.1 analyte yan. Okay. Divided by the volume total. Ano na yung total volume natin dito? We have 50 ml from the analyte and then 50 ml from the titrant. Diba? 50 ml na eh. So, 50, 50, 100. Okay? So, 100 ml na yung ating solution. Okay, ibig sabihin nun yung ating Erlenmeyer flask malapit na umapaw. And 250 ml nga pala yung Erlenmeyer flask. Yan yung capacity niya. Multiply mo yan sa Kb. Ano yung Kb? Sabi natin dito, Kw over Ka. What's Kw? 1 times 10 raised to negative 14 divided by, ano yung Ka? 1.8 times 10 raised to negative 5. Concentration ng OH makukuha mo dyan. Gagawin mo, pag na-solve mo to, concentration ng OH makukuha mo dyan, gawin mo ang POH, then isubtract mo siya sa 14. Okay? So, ganun ha. Pa-plug in ko na siya dito sa Calcu. O recycle ko ulit. Yan. Plug in tayo sa Calcu. Plug in ko to. Ganito yung mabilisang ginagawa ko dito na pag nagsosolve ako. Share ko sa inyo. Kunwari, I want to get the pH, di ba? Sabi ko sa inyo, pH is equals to negative log. I mean, kunwari may POH ako, gusto kong kunin yung pH. Zoom in ko ulit. Wait lang. So, ginagawa ko 14 minus POH. And you know, POH is negative log nito. So, ginagawa ko minus log ng OH. So, ginagawa ko sa Calcu, pina-plug in ko ito dito, then tinatype ko tong equation na to as a whole. Let me do that na para ma-try nyo rin. 14 minus negative log. Then, pa-plug in ko na to. Square root. Okay. Then, 50 times, oops, mali. 50 times 0.1 divided by 100. Then, times the KB. Okay. So, another fraction. Fraction ulit. 1 times exponential eh. So, ito yung pipindutin mo. 1 times 10 raised to negative 14 divided by 1.8 times 10 raised to negative 5. Okay? So, yun yung ginawa ko. Pakita ko ulit. Lakihan ko tong Calcu. Ito yung ginawa ko ha. 14 minus negative log. Okay. So, ito negative log. Ito yung POH. No? So, 14 minus POH lang yan. Pero pilinag-in ko na lahat. Minus the negative log. Then, yung expression for the OH. This is the concentration of the base. MAVA over V total. Times the the KB calculation. So, that's KW divided by KA. So, ganun ginawa ko. Enter na, enter. Ayan, 8.72. Pwede ko pala i-ganyan, no? Ngayon ko lang nalaman. So, the pH at equivalence point is 8.72, which is consistent sa sinabi ko kanina that the pH at equivalence point for a weak acid strong base titration is greater than 7. Bakit uli ganon? Kasi conjugate base meron tayo sa solution. Conjugate base meron tayo sa solution, kaya ganun. Okay. Kaya siya basic. Okay. So, iba yan sa strong acid, strong base. Kasi ano meron tayo at equivalence point kapag strong acid, strong base? Tubig lang, pati salt. Sino nagko-contribute doon? Edi yung tubig lang. No? Dito, ano nagko-contribute dito is the conjugate base. Kaya basic ang solution. Okay. So, yan. Ayan, malapit na tayo matapos sa isang item pa lang. No? Papansin nyo, no? Isang problem, inaabot tayo ng 1 hour. Ganun ako kadaldal. Kasi kapag ibang prof to, tapos na agad tong PowerPoint na to. Pero ako, gusto ko hanggat maaari explain lahat bakit naging ganun, no? Para pagdating ng exam, hindi nyo natatanong bakit hindi ko to masagutan? Ang kailangan, ang sagot nyo doon sa exam is answer na, no? Okay. So, inihimay-himay talaga natin yung stages and the equation para masundan. Okay. And hopefully nasusundan, no? Okay, hindi kasi tayo face-to-face eh. Pag face-to-face, may nakikita ko man nakaganon yung muka, na nakakunot yung no. Ibig sabihin, tinatry nila i-digest. No? Pero since ano tayo online, di ko alam kung nakakunot ba yung mga ulo nyo dyan. No? Sabihin niya lang pag may question, ha? And hopefully, I'm making myself clear sa bakit ganyan yung ginagamit natin. Okay? Bilang ano kasi scientist tayo lahat, no? It should be dapat common sa atin magtanong bakit ganun, no? Bakit ganyan, no? 'Di ba pag nangungopia din naman tayo, sinasabi natin, "Ba't ganyan sagot mo?" 'Di ba? Ba't ganun din tayo pag sinasagutan ko 'to, "Bakit ganun?" No? Pag nangungopia kayo ganun eh. "Ba't ganyan sagot mo eh sa akin ganito ganyan na." 'Di ba? Guilty tayo doon, no? Kasi nung ako rin naman nagtatanong ako dati. Pag assignment nga lang, pero pag exam hindi. Isa ako sa mga maukunat na student dati. Pagdating sa exam, walang makakakopya sa akin. Tsaka hindi rin ako nakakopya. Okay. Sa majors. Sa majors yun ha. Pag minor, di ko sure. So yan. Kasi pag major, board exam subject yun eh. Okay. So yan. Baka isipin nyo, hala, hindi naman to board exam subject. Hindi, core tayo. Core subject ako. So, seryosohin nyo pa rin. Okay. So, core subject to, kaya important to. So, wag pa rin kayo magkopyahan, ha? Okay. Post-equivalence point. Sabi natin, the pH is contributed by the excess base, no? So, the equation here is MTVT minus MAVA divided by V total. However, I want you to use the new equation, no? Na sinabi ko. So, that's VT minus VTEP times the MT divided by the V total. Okay. So, same lang to sa MTVT minus MAVA. Okay. Because we are getting the excess mole of the base. Kaya ganyan yung equation. Ito yung excess volume ng base, concentration ng base. Makuha mo doon, edi excess mole divided by the V total. Kaya ganyan yung equation. Plug in na lang. Plug in. Erase ko to kasi ang daming sulat. Sana sa quiz mataas kayo dito, no? So that's VT minus VTEP, which is 50 times the concentration of the base divided by volume total. Ano yung volume total? 50 sa Analyte and 50.1 sa Titrant. Okay. So 100.1 na yung ating total volume. Okay. Kalahati na siya ng Erlenmeyer flask. Plug in natin dito. Plug in, delete, delete. Okay. Ito, OH to. Gagawin ko yung shortcut natin, ha. pH minus POH, no? So, that's 14 minus negative. Again, yung negative, pipindutin mo yun dito. Papansin mo naman yan eh. Mahaba yung minus sa negative, no? Minus negative log, then fraction. Nawala. Ay, mali. Ayan. Ba yan? Anyway. Ano yun? 50.1 minus 50. Ay, kulang ako ng fraction. Sorry. Ay, parenthesis. Gagamit tayo ng parenthesis kasi PEMDAS. Those parenthesis times 0.1 divided by V total 50.1 plus 50. Yan yung pH ng solution. 9.999 something something. Nabura ko yung equations. Anyway, may sagot naman sa next slide. You can round this off to 10, no? 2 decimal places tayo eh. So, ayan, nabura ko yung equation kasi nirestart ko yung PowerPoint. This is the answer. Okay? So, na-explain ko na bakit ganyan-ganyan yung bakit ganyan yung equations. No? So, this is the CA minus KB. Ito, ginamit ko dito yung new equation. Mas maigsi siya kaysa sa MTBT minus MAVA. No? So, yan. Okay, so yan. If you graph that, ganito yung itsura. Okay, basta something like that. Dahan-dahan na akyat, then inflection point. Okay. Pag dahan-dahan umakyat, buffer yon. Okay, so hindi ko na i-graph ha. Ayan. Siguro itong mga to, at home na lang, no? Practicein nyo na lang din. Kasi masyadong matagal tayo eh. Okay. So, gusto ko talaga kasi himayin yung step by step, no? Okay. So, since nahimay na natin yung step by step, you know the equations to use, no? And bakit yun yung equation na ginamit natin? Sagutan nyo na lang to at home, no? Sa bahay naman kayo, kaya sasagutan nyo talaga siya. Okay. So, yan, sagutan nyo na lang to. Then, I will upload the answers, no? Sa next meeting. However, ito pala, no? Sa Monday ay Academic Integrity Day daw, no? Para sa yung araw na yon, hindi ako sure. So, Academic Integrity Day daw yon. Feeling ko may activities kayo sa FEU. I don't know, no? Kaya walang klase that day. Pero meaning nun, asynchronous tayo. Okay? So, async na lang tayo. Okay, para tuloy-tuloy na. Mag-upload na lang ako ng video sa that day. Okay? So, yan. Papakita ko doon yung answer dito. Okay? So, sagutan nyo yan. Again, malalaman mo kapag weak acid kapag binigay yung Ka. Pag hindi, hanapin sa table. And table ay binigay ko last chapter. Balikan nyo yung PowerPoint na yan. Okay? So, yung unang sinabi, yun yung analyte. Formic acid is a weak acid. NaO is strong base. So, you know, this is WASB. Next, hanapin si BTEP. Asa kaya yung BTEP dito? Hindi ko sure. Hindi ko sure kasi hindi ko pinipindot yung calcu eh. So, hanapin nyo, saan yung BTEP? Sasabihin nyo, kunwari, ito kunwari lang hindi ko sure kung ito yun. Okay. Kunwari, ito si EP. Ito, pre-EP, post-EP, initial. Yung 0, malamang initial yan. Okay, apply the equations. Initial, square root of Chaka. Pre-EP, Henderson-Hasselbalch, pKa plus log, conjugate base over remaining acid. Equilibrium, equation is OH equals square root of conjugate base concentration times the Kb. Okay. And post-equivalence point, ang bagong equation ay Vt minus Vtep times molarity titrant divided by the total volume, which is same as MTVT minus MAVA over V total. Basically, sundan nyo na lang to. Pero again, it is better kung alam nyo kung bakit sinusunod yon. Okay. So, hindi lang tayo blind followers. No? We are critical thinkers. No? Ganun dapat. Hindi porket sabi sa PowerPoint ganito, ganun na. No? May explanation. Yun yung critical thinking. No? Kasi college na tayo, kailangan critical thinkers tayo. Kaya ini-explain ko talaga bakit. Okay? So next one, we have the monoprotic WBSA. Wabsa. Okay. So we have the weak base strong acid titration. Kung ano na una, yun yung analyte. So the analyte here is the weak base, no? And the titrant is the strong acid. So if you will graph it, no, it will look like this. You will start with a very high pH kasi weak base yon. And then bababa siya slowly. Then ang last natin is the strong acid na lang yung matitira. Okay, so yung pH ay mababa at the end of the titration. Okay, so ganito yung graph niyan. That is reverse of the WASB kanina. Okay, kanina sa WASB dito eh. Ngayon ito ganun. Okay, similarly we also have buffer system dito. Okay, we have a buffer system because when we add the acid, some of the base is converted to the conjugate acid. Okay, when you add acid, some of the base is converted to conjugate acid. Kaya ganun. Kaya may buffer tayo. Okay, so since we are in the basic solution, ang buffer equation na gagamitin natin ay yung basic, no? Yung basic version ng Henderson-Hasselbalch, no? And then we have the equivalence point and the post-equivalence. So, isa-isahin natin yung equation, no? Isa-isahin natin. Okay, so yan, initial, pre-equivalence, post, no? Species present, and the equations. Initially, we have a base, no? The constant and of the two species, ang magko-contribute sa pH ng solution ay yung base, no? Okay. Yung base yung magko-contribute sa yung weak base yung magko-contribute sa pH ng solution. And when our base dissociates, no, in aqueous solution, we get OH, no. Yung base, pag nag-react yan with water, this is the equation, we are producing OH. That is KB equation. So, KB equation yan. Kung ako naalala pa equilibrium, gets agad yan, no? So, this is KB kasi base equation yan eh. We get OH on the product side eh. So if you write KB for this equation, that is the concentration BH plus concentration OH minus divided by concentration of base. Yung water, di nilalagay. Alam nyo na kung bakit. Okay? Kasi water is constant ang kanyang concentration. So we assume the two are equal. So we get x squared. Concentration of base minus x. We assume small x. No? So we can reduce that to KB equals x squared CB. So x is the square root of CB KB. Ayun. Okay. So sa equilibrium lang yan naka-base. No? So ayan. Yan na yun. Okay. Okay. So this is based on equilibrium. Similar to weak acid. Pre-equivalence. Ano nangyayari sa pre-equivalence? Nagdadagdag ka na ng titrant na acid. Ibig sabihin nun, some of the base is converted to the conjugate acid. Nadadagdagan ka na ng conjugate acid. Okay. So we will use the basic version of the Henderson-Hasselbalch equation, which is POH equals PKB plus log conjugate acid divided by conjugate base. No? So this is the equation to be used. Okay, dalawa yan ha. You have the pH version and the POH version. Okay? So yan. So bakit POH version gagamitin natin? Kasi base to eh. Kaya base version. Okay? PKB, negative log lang yan ng KB. KB will be given. O kaya nasa table dun sa previous chapter natin. Mag-upload pa ako ng KA, KB values na marami. Hintayin nyo na lang sa discussion sa Canvas. Okay. Then you have this. Ayan. Gagawin natin, yung conjugate acid. Tumataas yung value niyan because of because we add titrant, no? So we can express this as MTVT. Ganun pa rin, no? And yung base natin nababawasan when we add titrant. So we determine how much is left. So MAVA minus MTVT. Same lang din sa kanina, no? Ganun. Conjugate acid, nadadagdagan kasi nagdagdag ka ng titrant. By how much? Equal moles sila. Okay. Ang base na babawasan kasi nagdadagdag ka nga ng titrant. How much is left? This much, no? Mole acid minus mole titrant added, or the moles, moles base minus mole of the acid added. Baliktad nga pala tayo. Okay, so yan yung equation. Plug in. Okay, plug in mo lang. You will get the POH. Since gusto natin pH 14 minus this lang. Okay. So yan. Equivalence point, what happens here is that all of the base is converted now to the conjugate acid, no? So all of the base is converted to the conjugate acid. Okay. So to express the concentration of the conjugate base, conjugate acid, nabubulol-bulol na ako. So to express the concentration of the conjugate acid, that is the amount of the base, no, divided by the volume total, no. Bakit? Kasi sabi natin at equivalence point, the amount of base is equal to the amount of the conjugate acid, no. Doon na siya fully converted to the conjugate acid. Kaya we use this equation. Similar lang din sa kanina, no? Nagpalit lang tayo ng symbols pero same idea. Okay? Lahat ng base naging conjugate acid na. So we can use this equation. Ka na ngayon, no? Bakit Ka, no? You may ask, bakit Ka? Acidic na kasi yung solution natin dito, no, at equivalence point, because of the two species, no, which of them will contribute to the pH of the solution? Ang sagot ay yung conjugate acid, no. Conjugate acid na yung dahilan bakit may pH yung ating solution. Why? How pala? If you react the conjugate acid with water, ano mapaproduce natin? H3O+. We have an acid. And since we produce an acid, this is Ka expression. Okay? So, ganun. Mapansin nyo, no? Parang bumalik yung base natin. No? Bumalik siya, pero mas dominant na yung acid natin. Kasi, tignan nyo, wala nga akong nilagay na B dito. No? Kasi, wala na to eh. Virtually ubos na to. Okay? So, ito na lang yung natitira talaga. So, yun na yung idea. Yung ating conjugate acid, it reacts with water to produce hydronium ion or H+, no? Or H3O+. So, this equation is Ka. Okay? So, same equilibrium process, no? That's Ka equals, x squared divided by HB minus x. Burahin mo yung x, small x kasi. So, x is equal to square root of CHB plus Ka. CBH plus pala. Times the Ka. Okay. So, yan. Pinagbaliktad ko lang. So, yun yung dahilan. Equilibrium lang din. Okay. As long as you know the equilibrium, gets mo na to. Pero, yan. In-explain ko. And then, post-equivalence point, no? Tatlong yung species present natin. We have the water, the conjugate acid, and the excess acid. Sino mas malakas? Di malamang yung excess acid because siya ay strong acid. Okay, so yun. Ito yung mas malakas. That means the pH of the solution is solely based on the excess acid amount. Okay. So to determine the amount of the excess acid, we use this equation, or you can use this Vt minus Vtep times the molarity of the acid divided by the total volume. Right, so mapapansin nyo, same lang din sa kanina, no? We just replaced yung acid, ginawa nating base, no? Okay. And yung base ginawang acid, no? Yung Ka ginawang Kb, no? Then yung Kb ginawang Ka. So ni-reverse lang natin lahat, no? Because the process is reversed, no? So that's the overview of why the equations are this, no? And hopefully clear tayo doon, no? Nakwento ko na naman kanina, etong part na to binaliktad lang natin lahat uli, no? Flinip lang natin yung equations. Kanina pH to, ngayon POH na siya. Okay. So if I will ask you, what is the pH at equivalence point? Okay. What is the pH at equivalence point? Is it greater than 7, equal to 7, less than 7? Sige. Try ulit tayo. What's the pH? Less than 7. Ayan. Gets na kung bakit Kasi ano meron tayo at equivalence point? Conjugate acid. Acid, no? Acid. Ibig sabihin, mababa pH, no? Unlike kapag weak acid, strong base, ano meron tayo at equivalence point doon? Conjugate base. Base, no? Ibig sabihin, mataas yung pH. Greater than 7. Okay? So, yung mga keywords na yon, no? Yung mga ini-emphasize ko, makakatulong yon sa quiz, no? Kasi, tatanungin ko ulit to sa quiz, eh. So, nakakailang points na kayo? Tatlo na, no? Tatanungin ko what is the pH of the solution kapag SASB or SBSA titration. 1 point yon, 7 yon. Kapag WASB, ano yung kanyang pH at equivalence point? O, malamang greater than 7 kasi we have the conjugate base, no? May base tayo at equivalence point. In this case, WBSA, no, at equivalence point we have the conjugate acid. So, ibig sabihin, mababa yung pH. Okay? So, yun. So, yun, no? Good tayo dun. Okay? Nagigets na sana, no? Pag may question, don't hesitate, no? Huwag mahiya magtanong, no? Okay lang. Hindi naman ako katulad ng ibang teacher na nagwawala, no? Bakit di nyo to alam, no? Hindi ako ganun. Kasi as a student, marami rin akong tanong sa teacher ko. Dapat gusto ko ganun din kayo. Magtanong kayo na magtanong, no? Okay. Para mas masundan, no? Tsaka hindi acceptable yung ganun talaga, no? Okay, may mga ganun kasing teacher, di ba? Bakit ganyan po equation na ginamit namin? Ay, ganun talaga yan. Okay, ano yan? May explanation yan. It's either equilibrium o kaya stoichiometry ang dahilan. O kaya dilution equation. Okay, so yan. Try natin this. Fast-paced tayo kasi alam na natin gagawin natin. Okay. Tapos bibigyan ko rin kayo ng ng shortcut, no? Shortcut kung paano mabilis makita si BTEP kahit di ka na mag-calculate, no? Kahit i-mental mo na lang siya. Okay. So, ganito. So, yan. Una sinabi, 50 ml of alico. Alico basa dyan, hindi yan aliquot. Alico. Ganito pronunciation, alico. When you say alico, ano yon? Nakwento ko na to chapter chapter 0. Ito yung first week ng classes natin. Nakwento ko 'yan. When you say alico, that is a small portion of the liquid, no? Kumuha ka ng liquid. Small portion lang. Kunwari, meron kang 1 litrong tubig, nilagay mo sa baso mo, 10 ml, hindi, 100 ml. So, yung nasa base mo, alico yun ng nasa lalagyanan. Ibig sabihin, mamaya, kumakain na siguro kayo ng lunch, no? Kunan mo ako ng alico ng juice, no? Yan. So, ibig sabihin, kumuha doon sa container, no? Maglagay sa, sa baso. Alico, di ba? Ang arte namin, no? Ganun talaga kami mga chemist, no? Daming terms. So, alico, portion of the whole, no? Anyway, so kumuha daw siya ng 50 ml of this acid, of this base, no? This is the KB. Tinitrate siya with this. Calculate the pH, no? So, ano yung shortcut dito? Ganito. Ang shortcut ko para makalaman kung sino yung VT. Ganito lang. Hindi ko na pinapansin yung mga zero eh. 5 times 5, 25 divided by 1. Ibig sabihin 25 o something na 25 yung sagot, no? Okay. Pwedeng 2.5, pwedeng 250, pwedeng 25, no? So, hindi ko na pinapansin yung decimals. Yung numbers lang. Okay. Kunwari, 2 times 3, 6 divided by 1 is 6. Siguro 60 ml yon or 6 ml, no? Shortcut lang. Okay, so 5, 25 times 1, 25. So, ibig sabihin, ito yung VTEP natin. Okay? Shortcut. Yung non-zero digits yung i-multiply, divide mo na lang. Okay? Hindi ko na papakita yung calculation ng VTEP, no? Alam nyo na yan. Okay? So, ayan. So, since this is the equivalence point, this is the post. Okay? the pre-AP and the initial. Malamang initial yan. Okay. So, since alam nyo na yung ating mga stages, no? So, let's apply the equations na ating gagamitin. Yung equations na sa previous slide, no? Download nyo na lang yung PDF. Initial square root of CBKB yan. Square root of CBKB. What's the CB? Ano yung CB? Curriculum vitae. Vitae talaga, no? Ang corny na. Pagbigyan nyo na. As KB is 1.61 times 10 raised to negative 5. Minimize ko to ba? CBKB lang yan. Tatype ako dito. Okay? OH yon. Gusto ko PH. Gagawin ko yung shortcut ko. Ano yung shortcut natin? Pag gusto mo PH agad, so type mo 14 minus negative log kung ano man yung OH expression mo. Okay? 14 minus negative log of the square root. Tuloy-tuloy mo na. Ganun din naman eh. Okay. Para isang pindot lang may sagot ka na. But if you are quite confused sa ganun, edi mag-step by step ka na lang. But para mas mabilis yung class natin, type ko na lahat, no? Ito yung screen ng aking calcu. 14 minus negative log square root ng CB KB 1.61 times 10 raised to negative 5. Sagot is 10.95. Again, para makita nyo kung ano yung type ko. 14 minus log square root of 0.05 times the KB, 1.61 times 10 raised to negative 5. Okay tayo dyan. Okay. So, yan. Very good. So, yan. 10.45. 95, sorry. Pre-equivalence point, buffer yan. However, since basic solution yan, we use the POH version. POH equals PKB plus log conjugate base divided by the conjugate acid divided by the base. Sorry. Okay. So conjugate all divided by the base. No? Okay. PKB, negative log nyo na lang yun. Negative log na natin. Negative log ng 1.61 times 10 raised to negative 5. 4.79 na lang. Iyan mo na yung ibang decimal. So, PKB is 4.79, sabi ng calcu. Plus log on the numerator. Again, gano'ng karami yung conjugate acid? That's equal to the amount of titrant added. MTBT. How much base is left? Okay. That's the difference of the base minus the titrant added na. So, MABA minus MTBT. Yung titrant kulay black. Okay. Titrant is black, 0.1 times 10. Denominator tayo, MAVA minus MTBT. MABA, yung Analyte orange. So, that's 50 times 0.05 minus, parenthesis, no? Minus MTBT, o kopyahin mo na lang yun sa numerator, 0.1 times 10. Okay? Sulat nyo na. Minimize ko at type ko sa calcu eh. Zoom nyo na lang pag di nyo pa nakita. Pero hopefully marunong na kayo magsulat nan. Delete ang calcu. Yung calcu yung dinelete na. Okay. Ano to? POH makukuha Gusto ko PH So, POH muna. Solve natin POH. POH muna. Okay. 4.79 plus log fraction 0.1 times 10 divided by parenthesis. Ay, mali. Yan. Analyte close parenthesis minus titrant close parenthesis. Ay, math error. Okay. Sobra na ako ng 0. Sorry. Yan. Pag nag-math error, mapapansin nyo, no? Kunwari, math error. Pindutin nyo yung left-right, no? Sasabihin nun kung saan kayo nagkamali. Kunwari, dito lumabas yung cursor. Ibig sabihin, somewhere here ka nagkamali. Okay. Alam nyo dapat yung sinasabi ng calcu nyo, no? Kunwari, dun siya huminto sa part ng equation. Ibig sabihin, dun may mali, no? Okay. So, ganun. POH to ha. Again, POH yan. Baka mag-isip kayo, wala acid to. Hindi, POH yan eh. 4.61 yung POH natin. So, since this is POH, gagawin natin pH. So, paano yon? 14 minus the answer. Yan yung sagot dapat. Ang ibig sabihin, alam nyo na kung saan ako manggugulo sa saan ako manggugulo sa quiz. Kunwari, POH na solve nyo, pero gusto ko pH, lalagay ko pa rin doon yung POH, no? Para malito tayo. Para mag-isip talaga tayo, no? Okay. Para careful kayo. Tsaka anyway, ang quiz nyo naman is 2 attempts na, starting the sa finals period. 2 attempt ibibigay ko para makabawi na, no? Okay. Kasi kita nyo naman yung grades nyo, no? Transparent naman tayo sa grades. Para makabawi, edi 2 attempt na. And hopefully makatulong yan, no? Makabawi talaga kayo ng scores, no? Okay. So, yan. Okay, so at pre-equivalence point, the pH is 9.39. Again, yung 4 point something doon kanina, ano yun ha? POH yun. Yung 4.61 POH yun. Ito yung gusto natin. Hindi ko na pinapakita dito sa table kasi matik na dapat sa isip natin yan, ha? Okay, matik na. Nawala. Ayan. Equivalence point, ano meron tayo dito? Acid na. So we can write H plus equals square root of the conjugate acid concentration times the Ka. Okay? So yan. Okay, so yan yung ating equation. Oops. Yung concentration ng ng conjugate base, conjugate acid, sorry. Yung concentration ng conjugate acid, saan galing yan? Sa analyte lahat, no? We assume at equivalence point, all the analytes have been converted to the products. So this is equal to MAVA divided by V total. Ito, sinasabi na itong numerator, yung mole ng mole ng ating reactant na convert na to product. Itong V total, dilution equation to. Okay. O KA, meron tayo KB. Paano yan? KA, KB equals KW. So to solve for KA, that's KW over KB. Okay? So, gets na dapat yan, ha? Burahin ko na to. Plug in ko yung numbers. Let me plug in the numbers kung ano itatype nyo sa calcu. Kung alam nyo na itatype nyo sa calcu, better. Okay? Better kapag ganun. Oh, MAVA. So that's 50 ml times 0.05 molar. Yan yung analyte. Divided by the total volume. Ano total volume natin? 75 ml. Bakit? 50 ml analyte and then 25 ml titrant. So 75 ml. Times KA. KB meron tayo eh. So 1 times 10 raised to negative 14 divided by KB times 10 raised to negative 5. Ang kunin mo negative log niyan, you get the pH of the solution. Oh, let me type this sa calculator. Lalabas din naman to mamaya pag di nyo nakopya. And then, lalagay ko na nandito sa baba. Okay. Type ko to sa calcu. Ina-negative log ko na to ha, para pH na agad. Negative log square root na 50 times 0.05 divided by 50 plus 25 times, fraction ulit, 1 times 10 raised to negative 14 divided by 1.61 times 10 raised to negative 5. Enter. Yan na yung pH, no? 5.34. Okay. Ayan na. 5.34. Papansin nyo, at equivalence point, the pH of the solution is acidic because of the presence of the conjugate acid. Yan. Etong 5.34 na acidity na to, para tong ka-level to ng ano nga ba ka-level niyan? Ang laway kasi natin, around 6 yan. No? Siguro ka-level to ng wine. Yan. Pero wag nyo tikman to pag nag-lab kayo. No? Delikado to. Cyanide yan eh. Yung cyanide ay isa sa mga dahilan ba't maraming namamatay kapag di ba nababalitaan nyo dati yung cyanide poisoning? Yung umiinom ng silver cleaner. Kaya bawal na ngayon gumamit ng silver cleaner. Daming namatay dahil dun eh. Yung cyanide kasi, when it enters our body, it hijacks the electron transport chain. No? And you know, electron transport chain is one of the energetic metabolic pathways. So it produces most of the ATP needed for our cells. No? So, ibig sabihin, pag na-hijack nyo yung, pag na-hijack nyo yung electron transport chain nyo, patay talaga kayo. No? Instant yun. Okay. Kaya, yun. Bawal na yung, bawal na yung silver cleaner. Cyanide gamit dun eh. Okay. So, bawal na yan. Meron din yan sa mansanas, kaya sabi sa inyo, yung buto ng mansanas, wag nyo kainin. Okay. Pero yung yung content nun sa buto ng mansanas is super onte, no? Parang sandamukal na buto pa kailangan makain bago mag-effect yung cyanide. No? Okay. Ayan, share ko lang. Post-equivalence point, we have excess titrant. So the pH is dependent on the amount of the excess titrant, which is HCl. Let's use the new equation, Vt minus Vtep times the molarity of titrant divided by the V total. Okay. 26 ml to. Vtep is 25 times the molarity of titrant, which is 0.1. divided by the total volume. Ano total volume natin? 50 ml analyte, 26 ml titrant. Baka isipin nyo 26 plus 25. No. No. Hindi po. Okay. Baka ganun kasi isipin nyo, pag-add ko lang to. No. Analyte plus titrant dapat. Ha? Okay, negative log natin yan. Lalabas yung sagot. Let me type it sa calcu. Parenthesis. 26 minus 25, no? Actually, pwede mo i-type 1 na lang, pero lalagay ko pa rin para may reference kayo. 0.1 divided by 50 plus 26. 2.88. Yan na yung pH ng solution. Ito yung equation na. Ayan. The pH of the solution when we add 26 ml of the titrant is 2.88. No? Okay, so that's how we solve weak acid and weak base titration curves. No? Titration problems. So ito, tinype ko na dyan yung solution. So alam niyo na, bakit ganyan yung tinype ko dyan, no? Okay, so may meaning lahat ng mga yan. Okay. Hopefully gets na sila. Okay. Pag di pa rin, pwede nyo ako tanungin. Okay. So yan. So answer this as well, no? This is practice, no? Application lang to ng ginawa natin kanina. So dalawa na yung assignment nyo, gagawin nyo. So, since kasi sa Monday, wala tayong pasok, no? Asynchronous tayo nun, no? Okay. So yan, kasi academic integrity day daw, no? So, yun na yung pahinga ng mga pillars of strength natin. Okay. So yan. So sagutan nyo na lang yan muna na atom. So dalawa na sasagutan nyo, ha? Practice makes perfect. No? So yan. Kahit wag nyo na i-graph siguro. Although ako i-graph ko pa rin. Wala lang. Okay. So yan. Let's talk about indicators, no? So this has been discussed in the lecture, I believe, kung nakapag-discuss na kayo sa lecture niyan. Okay. So when you say indicators, these are chemical substances that changes color depending on the pH value, no? And organic substances sila, no? So ibig sabihin sila ay mga big molecules, no? Mga organic molecules, no? Okay. So bakit kaya sila nagbabago ng kulay, no? You may ask, no? It has something to do with the electron distribution at different pH, no? Okay? So sa quantum mechanics kasi, biglang nag-quantum, no? Quantum mechanics kasi, depending on the number of electrons flowing around the molecule, there is a corresponding wavelength, no? Sa dami ng electrons doon. And the wavelength corresponds to certain colors, no? In short, sila yung mga molecule na kumukulay. Okay? So, ayan. Baka kasi tanongin nyo, bakit kaya sila nagbabago ng kulay? O yan, sinabi ko na sa inyo. No? Quantum mechanical description yan. No? So anyway, skip na tayo dun sa sa ganap na yan. So basta ang alam natin, indicators are molecules that changes color depending on the pH of the solution. No? And ano po yung indicator na pipiliin ko? Ano yung indicator na pipiliin ko? Kunwari, weak acid, strong base, no? Weak base, strong acid. Kunwari, strong acid, strong base. Ano kaya pipiliin ko, sir? Okay. Ang pipiliin nyo na indicator for different types of titration must correspond to the pH at equivalence point, no? Kailangan pasok yung pH at equivalence point dito sa pH range niya. Okay? So for strong acid, strong base, we usually use phenolphthalein. Siguro isip niyo, 'di ba sir 7 yung 7 to, 7 yung endpoint nito. Bakit yan yung gagamitin mo? Pwede naman bromothymol blue, 'di ba? Pwede naman, no? But again, ang common is phenolphthalein. Bakit? It has something to do with the inflection point. Mamaya sa next slide makikita nyo kung bakit. Okay, so may kinalaman sa inflection point why we prefer this over this. Tsaka mas cute kaya to, no? meron siyang element of surprise. Colorless din bigla-bigla magiging colorful, 'di ba? Amazing. So yan, phenolphthalein gamit namin doon. Okay? Paano naman po kapag weak acid, strong base o kaya weak base, strong acid, no? So, doon na tayo gumagamit ng other indicators, no? Pwede phenolphthalein pa rin gamitin mo. Sometimes we use methyl orange, no? Itong methyl orange, ginagamit namin to when the endpoint is acidic pH, no? Okay. We also use bromocresol green, no? So, pwedeng ito, pwedeng ito. So, dun sa titration ng natin kanina, neto, itong sodium cyanide, di ba, pansin nyo, the endpoint is 5.34, di ba? So, you may actually use either methyl orange or the bromocresol green. Kasi okay naman yung 5 doon eh. No? So, pwede mo gamitin either of the two. No? Isa lang, syempre, mamaya maging rainbow na yan. No? Pagpatak mo, naging rainbow. No? Iba na yun. No? Okay, so isa lang gagamitin mo doon. Okay, so again, to determine what indicator needs to be used is to identify, no, ano kaya yung aking endpoint, no? Ano kaya yung pH at endpoint? So, pwede mo yun i-calculate, no? And sometimes, fixed na yun, no? Nasa method na naman yun. Ara, sasabihin sa method, sa lab, gamit ka methyl orange. It must tell you that the pH at endpoint is 3 to 5, no? Kunwari, sinabi, gamit ka bromocresol green, no? It must tell you na ang pH at endpoint is 4.6, no? No, kunwari, nag-quiz tayo, multiple choice, sabihin, no? Ano yung pH ng solution? Tapos biglang sinabi niya yung indicator, alam mo na. Hanapin mo na lang kung ano yung pH range ng indicator. Yun na yung sagot na. Pero kung exact number yung hinahanap, edi solve mo yan. Okay? Pero makakatulong tong indicator to tell you kung asang pH matatapos yung titration. And ito yung color change niya. So, ito yung phenolphthalein. Ito yung nasa video natin last time. We started from colorless, naging pink, no? From acidic to basic, no? So, yan. So, ito yung iba't iba pang uri ng indicators. Okay? So, crystal violet, cresol red, thymol blue, erythrocin B, something, blah, blah, blah. Okay, so yan, marami yan. No? So sa lecture ko, kwento ko rin bakit ang daming ganyan. So share ko lang din sa inyo. Kasi the reason why marami tayong indicators that bukod sa iba-iba yung pH ng equivalence point natin, no? Some of these indicators ay specific sa ilang reaction kasi. Okay, specific lang siya sa ilang reaction. For example, Aerochrome black tea or the EBT, we use this sa EDTA titration, EDTA titration, or complexometric titration. Okay. So kung confused kayo, ano yon? Sinabi ko yon sa lecture. Okay. So panoorin nyo na lang. Or kung naturo na sa inyo ng lecture prof nyo, edi good na. So ayan. The reason bakit ang daming indicator is iba-iba kasi yung pH at endpoint na. But the commonly used is the phenolphthalein, the bromocresol green, the methyl orange. No? Ayan. So, yan yung mga common for acid-base titration. Okay. So, andyan yung color range nila. Papansin nyo, for every pH, nag-change siya ng color. Okay. So, from colorless to pink, from yellow to blue, no? Kaya bromocresol green, yellow to blue. May green kasi sa gitna, no? Kaya green sabi dun. Ibig sabihin pag green na yung color, endpoint na yan. Okay? Pag methyl orange naman, red yan kapag acidic, yellow kapag basic, no? Orange kapag endpoint, no? Diba? Na-imagine nyo yung bakit ganun pangalan nila. Sinasabi nila kung ano yung color niya at endpoint. Okay? So, yan lang. Okay. So, ito. For strong acid, strong base, this is the titration curve, no? So, depending on the concentration of your acids and bases, now you may use either of these three indicators, no? Okay, bakit yung phenolphthalein acceptable? Kasi look at the inflection curve. masyadong mahaba, no? So, when I say masyadong mahaba ang inflection point, no, or inflection curve natin, it spans a huge pH value. So, saan siya nag-start? Around pH 3 something. Saan siya natapos? Around pH 10. So, ibig sabihin nun, matatamaan niya yung color change ng PHP, phenolphthalein, bromothymol blue, and the bromocresol green, no? So, all these three can be used, no? Because ang ating curve, no, ang ating inflection point for the SASB titration is super haba, no? Madami siyang masasakop na color change, no? But again, the common one is the phenolphthalein, no? However, that is true when the concentration of your acid is high, no? So when we say high, mga point 0.05 and higher, no? Kasi, if the concentration of your acid is lower, for example, ito, 0.0005, ano na nangyayari? Yung inflection point natin lumiliit. No? Okay? So, lumiliit na yung ating inflection point. Yun yung effect ng concentration sa inflection point. The greater the concentration, the longer the inflection point. However, the smaller the concentration, the shorter the inflection point. So what is the effect? If your inflection point is shorter, then it will only span a few pH value, no? Ibig sabihin, hindi na siya pwede gumana sa BCG. Okay, hindi na siya pwede gagana dito. Sa phenolphthalein, medyo hindi na rin siya gagana. So, ibang indicator gagamitin mo. For example, bromothymol blue or BTB, no? Okay? So, yun yung idea, no? Yung length ng inflection point that will tell you anong indicators pwede ko gamitin. Okay? So, ganun ha. So, yun. Kapag mahaba ang inflection point, ibig sabihin, mataas yung concentration. Okay? So, ibig sabihin nun, you can use different indicators. However, the lower the concentration is, the shorter the inflection point becomes. No? And as a result, mas onti yung indicators na applicable. Kasi onti lang yung matatamaan yung color change. So, ito yung dashed line. No? Okay. So, ito yung mas mababa yung concentration. Mapansin nyo, better gamitin ang BTB or the bromothymol blue compared to the others. No? Kasi dun mas kita ang inflection point. No? Okay. But generally, sabi ko nga, generally, no? Ang concentration ng acids natin is ganito and higher. So, we use phenolphthalein. Okay? So, yan. For weak acid strong base, no? Weak acid strong base titration, again, ano yung pH neto? Ano yung pH ng endpoint ng weak acid strong base? Greater than 7. So, you can still use phenolphthalein. Okay? So, pwede ka gumamit ng phenolphthalein, bromothymol blue, okay. Bromocresol green, pwede ba? Hindi. Bakit? You will not observe the inflection point within the transition range of the BCG or the bromocresol green. Hindi kasi dumadaan doon yung inflection point eh. Ibig sabihin, hindi mo to pwede gamitin. Ang pwede mo gamitin is itong dalawa. But again, the commonly used one is the phenolphthalein. Phenolphthalein pa rin. Okay, kasi ang pH range niya is 8 to 9, no? 8 to 10. Okay. Napansin nyo naman sa calculation natin, di ba, kanina? Ano yung endpoint nun? 8.6, di ba? O, ibig sabihin, pasok yun dito sa phenolphthalein talaga. Okay? Similarly, the lower the concentration of the acid, the shorter the inflection point becomes. No? So, kapag maliit yung inflection point, then you may try considering other indicators, no? Para mas clear yung endpoint mo. Also, depending on the dissociation constant, okay, other than the concentration of the acid, yung dissociation constant, it also plays a role with the stiffness of the inflection point. No? So the higher the Ka, the higher the concentration, the steeper the inflection point. However, the lower the pH, the lower the concentration or the lower the Ka, mas maigsi ang inflection point. Okay? So, makikita nyo sa graph na to, we have decreasing Ka values pala. So, mas bumababa Ka values natin, what happens to the inflection point? Mas lalong lumiliit, no? And the shorter the inflection point, that means limited na lang yung indicators na pwede mo gamitin. Basta dapat pasok dun sa inflection point yung color change, no? Okay? So, yan. Ganon din sa weak bases, no? Same logic lang din, no? The weaker the smaller your KB, no? The shorter the inflection point then. As a result, mas onti yung indicators na applicable. Okay? Ayan. So, yun lang yung idea, no? So, again, paano tayo pipili ng indicator? So, the answer is depende sa haba ng inflection point, depende sa concentration, depende sa Ka, no? The higher the Ka, the higher the concentration, the longer the inflection point. That means the more mas marami tayong choices na indicator. Pero if mas maigsi yung inflection point, mas onti yung choices natin. Okay? And then ano yung indicator na gagamitin ko? Kailangan pasok siya dun sa sa inflection point, no. Okay? So kailangan pasok doon sa inflection point. Okay? So yan. As you can see dito naman sa mga common problems natin, phenolphthalein ang best na ginagamit kasi pasok siya sa inflection point. However, pag mas mababa yung pH, hindi na siya applicable. Okay? So yan. So ito daanan natin slightly. Dito tayo matatapos, no? Hindi wala na tayo siguro solving dito, or kung magbibigay man ako onti lang, no? So magbibigay naman ako ng worksheet with answers, no? Sa weekend na ako mag-upload, no? Kasi super hectic na ng schedule ko recently, no? Monday to Saturday na ako may klase, no? Kaya medyo nauubusan ako ng time, kaya pasensya na, no? Okay. Pero by the weekends gagawa akong worksheet, don't worry, no? Okay. So medyo busy na talaga, no? Okay. Kaya ganun. Okay, so let's talk about polyprotic acids-based titration. Okay, pag polyprotic, ibig sabihin mas maraming protons ang involved sa reaction. Pwedeng 2 to 1, 1 to 2, or 3 to 1, 1 to 3. No? Ano meaning nun? Pag may 2, ibig sabihin diprotic. No? An example ng diprotic acids and bases? Carbonate, okay, CO3 minus 2. So ibig sabihin diprotic yon. Sulfuric acid, H2SO4, no? So diprotic acid 'yon. Okay? So yung mga 'yon ay mga diprotics, no? Yan yung mga common. How about triprotic, no? Triprotic, it could be phosphoric acid, no? H3PO4, no? Tatlong protons yung magre-react. So triprotic acid 'yon. Triprotic base, parang wala pa ako na-encounter. No? So, yun yung common sulfuric, carbonate, no? And then, phosphoric acid. Okay? And remember that when we have polyprotic acids, no? Sabi ko to last chapter, the dissociation of H is stepwise. What does that mean? Okay. Ibig sabihin nun, kapag stepwise yung ating yung dissociation, ibig sabihin, iba-ibang inflection point makikita natin. Okay? Iba-ibang inflection point kada dissociation ng acid. Kada neutralization ng H. No? Okay? Take note nyo yan. Kunwari, diprotic acid, dalawa yung ino-neutralize na H. Ilang inflection point yon? Dalawa. So, ibig sabihin nun, dalawa yung endpoint natin. Okay? May endpoint for one H, then another H may isa pa siyang endpoint. For triprotic acid, tatlo. Kasi tatlong H yung ino-neutralize mo. So, ibig sabihin nun, tatlo yung inflection point. Okay? So, ganun. So, this is how the titration curve for diprotic acid looks like. We have two inflection points. Nakwento ko na to last time. Bakit dalawa inflection point? Kasi dalawang H ang in-neutralize mo. Ito muna, yung mataas yung Ka muna bago yung mababa yung Ka. No? And ganito, kung gaano karami yung volume ng acid, no? Kung gaano karami yung volume ng base needed to neutralize this first proton, kung gaano to karami, ganun din karami ang kailangan to reach the second endpoint, no? So ibig sabihin yan, kung 10 ml to, yung 20 ml, dun na manuneutralize yung susunod naman. Okay? Kung 5 ml to, ibig sabihin sa ika-10 ml, tapos na itong second one na. Okay? So, ibig sabihin, equal sila. Kung 5 ml to, 5 ml din to. 10 ml to, 10 ml din yun. Or total, 20 ml. No? Kunwari, 13 to, ito, 13 din. Itong part na to. Okay? Okay? So, equal yan. Equal. Okay? So, ganun mangyayari dyan. Take note, equal. Kasi magagamit natin to sa susunod na meeting, yung idea na yon. And again, pag diprotic acid or diprotic bases, kung ano yung endpoint ng isa, kung gaano karami yung volume na yon, ganun din karami yung volume to reach the second endpoint. Okay? So, yun yung idea natin. Take note. Okay? And then, ito yung mga equation that corresponds to the, that corresponds to the equations, no? Okay. So, ito yung mga species present for every step, no? Kapansin nyo, nagkakaroon tayo ng mga combination ng conjugate acid, conjugate base system, no? So, ibig sabihin, gagamit tayo ng mga buffer equation. And the other equations ay similar, familiar na lang, no? Okay. So, yan. So, lahat ng ito ay kinuha mula sa, kinuha ko yan mula sa equilibrium. So, isa-isa ko yan in equilibrium, pero shortcut ko to simplify it into this. Pag tinignan nyo to sa Khan Academy, sa Khan Academy, kay Professor Dave, kay Crash Course, kay Learn Organic Chemistry or Organic Chemistry Tutor, no? Leah Forsyth. Pag pinod yung mga YouTube videos na yun, iba yung nilalagay nilang equation. Equilibrium kasi sinusundan nila. For me, equilibrium pa rin naman. However, I use the small x approximation. Kaya mas madali yung equations. Kasi meron kayo makikita pag ginugol nyo, may ganito nakalagay, K1, K2 plus concentration, K something divided by K blah 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 blah. Daming nakalagay, di ba? Maski ako nalilito pag ganun eh. Kaya ganito ginawa ko, shortcut. Okay? So, yan. So, don't worry. Magbibigay na lang ako ng problem na itong equations gagamitin nyo. Onti lang, as in onti lang. Kasi ang primary focus ko yung mga monoprotic talaga. Okay? Okay. Pag BS Chem, yan, magsasawa ka dito. Pero, naman tayo. Hindi tayo BS Chem, kaya hindi tayo magganito masyado. Okay, magbibigay ako isa or dalawa lang sa worksheets. No? Kasi onti lang talaga yung ganun topics natin. Okay, triprotic acid, ganun din, tatlong inflection point. Bakit tatlong H ang ino-neutralize? Take note that kung ano yung volume to reach the first endpoint, ganun din karami to reach the second endpoint, and ganun din karami to reach the third endpoint. No? Equal lang din lahat. Okay? So, 5 ml to, 5 ml din to, 5 ml din yun. Okay? 10 ml to, 10 ml yun, 10 ml din yun. Okay? So, equal ang hatian kapag polyprotic acids. No? Ito yung equation, mas marami. Bulaga. Okay, kaya hindi na tayo magsosolve nito. Kasi mamaya ma-stress na kayo. No? Kita ko na lang kayo, nag-walling na kayo sa stress na. Hindi na natin gagawin yan. Okay? Diprotic base, example nito is the carbonate na i-discuss uli natin last chapter. sa last part ng discussion. No? So, carbonate, ganito yung itsura ng titration curve niya. So, mapansin nyo, dalawa ang inflection point kasi it needs 2 proton for it to be neutralized. No? So kung gaano karami ang volume to reach the first endpoint, ganun din karami ang volume to reach the second endpoint. Okay? So kung gaano karami to, ganun din karami to. 5 ml to, 5 ml yon. 10 ml to, 10 ml yon. Okay? That's the idea. And yan yung mga corresponding equilibrium equations. Pag in-apply mo yan dito, you will get these equations. No? As you can see, whenever you have a buffer system sa pre-equivalence point, no, magkakaroon ka ng buffer equations. And ito yung mga other equations necessary to calculate for the concentration of the species needed. No? Okay. Ayun, tapos na. Ito yung didiscuss ko. Asynchronous to. Kasi walang pasok sa Lunes. Okay. Makakapagpahinga ang mga pillars of strength natin. Okay. So, yan. Hindi nyo pa ito may-gets pag binasa nyo to agad. No? Pero, i-discuss ko naman to. Ito yung idea ng titration curve. No? Kunwari, ito yung phenolphthalein endpoint. Ito yung bromocresol green endpoint. Kailangan yung inflection curve dadaan sa transition range. Okay. So, ganun. Okay. So, yun lang. Okay. So, again, async tayo sa Lunes. Okay. So, yun. Then, mag-upload ako ng worksheets sa weekends. No? When I say weekend, hindi Sabado yan. Linggo yan. Okay. Sabado baka nagbabawi pa ako ng tulog. No? So, expect Sunday yan. Doon na yung worksheet, including the last topics. Okay. So, ayun, hopefully clear tayo sa weak acid, weak base, weak acid, strong acid, weak base, strong acid. Siguro tataka kayo, no? Sir, meron bang magtataka kayo siguro, no? Kasi merong weak acid, strong base, weak base, strong acid, may strong acid, strong base, no? Strong base, strong acid. Kung may mga ganyan, meron bang weak acid, weak base? You may ask yourself, no, meron ba? Ang sagot ay wala. Bakit? Parehas nga sila weak eh. Imagine nyo, dalawang may hina mag-react sa isa't isa. Anong gagawin nila? Wala. Okay. So, ganun sa chemistry. Pag parehas silang weak, walang mangyayari. Okay. Kaya wala tayong weak acid, weak base titration. Ayan, pwede ko ilagay yan sa quiz, no? Baka may tricky na. Pag may nagkamali pa dyan, ako po. Mali na yon, mali yon. Okay. So, kailangan at least may isang strong para mag-react. Kasi kapag parehas silang mahina, walang mangyayari. Okay? So, maghahalo lang sila. No? Kaya nga minsan napapansin nyo sa condiments natin, may mga molecules din na strong acid, may mga molecules din na strong base, pero hindi sila nagre-react to one another. Kasi parehas silang mga weak. No? Pag halu-haluin mo, suka, tapos yung juice, no? Tapos basta pag halu-haluin mo yung mga ganong chemicals, walang mangyayari, no? Okay. Kasi pares nga sila weak, okay? So, yan. That will end my session today. So, for Monday, ito yung topic natin, no? And hopefully clear tayo sa calculations dito, bakit naging ganun sila. For polyprotic acid-based titration, wag nyo na damdamin yan, okay? Kasi hindi na ako bibigay ng mga ganyan masyado, no? Siguro yung diprotic, yes. Pero, onti lang. Sa worksheet, dun ko ibibigay yung with explanation. Okay? So, yun lang. I hope na nasundan yung discussion mula sa una hanggang ngayon. And itong next meeting, logic na lang tayo dito. Wala na tayong gagamitin na square root of tsaka dito sa last meeting natin. Okay. So, medyo intensive tayo sa calculation. Pasensya na. Ganun talaga, no? Ganun talaga ang chem. Pero again, ang pinaka-konsepto lang naman nito is lahat ng equation ay nakabase dito sa apat na to. Sa stoic, sa dilution, sa equilibrium, and sa buffer. Diyan lang umiikot yung equations natin. Okay? So yan, wag nyo kabisaduhin. Pwede mag-index card. Or pwede yung notes nyo na buksan nyo habang nagko-quiz. Okay lang yun sa akin. Okay? Ang mahalaga, alam nyo kung bakit naging ganun yung equation. At alam nyo bakit ganun yung process natin. Okay? So yan, so develop critical thinking skills, and with that, no, I will end the session today. Hopefully may natutunan tayo, ha. So thank you, and I'll see you again next week, Thursday, kasi sa Monday wala tayong classes sa Monday dahil Academic Integrity Week. Nakalimutan ko kung para saan yun, no? Pero sabi walang pasok lang. Okay? So enjoy that day, na magpahinga na lang muna kayo that day. Okay? So have a great day, and good luck sa iba niyo pang classes today. I'll see you again next week. Bye-bye. Save ko lang. Stop recording. Ayan, ingat, and bye-bye.